This is 2.7 part 5. In this question we have a slightly different scenario than we've had in previous questions. It says from a small plane, so the plane is located right here, the angle of depression of a sailboat is 21 degrees. That means if you're up in the plane, if you look down at 21 degrees, you're going to see the sailboat. And then back up in the plane, if you look down in the other direction at an angle of depression of 52 degrees, you're going to see the ferry boat. The plane is flying at an altitude of 650 meters. How far are the boats to the nearest meter? And what you notice about this question is that the angles that were given aren't exactly in the triangles that were drawn. There's a couple ways to do this, but the easiest way I've decided to teach you to solve this question is to actually draw the triangles upwards. So you're going to extend this line upwards and this line upwards, and you're actually going to look at these triangles instead. Now keep in mind that if you draw this line straight upwards, you're creating a right triangle up here and a right triangle up here. So let's redraw that situation, and we're going to have that and that. So this is where the 52 degrees is, obviously not drawn to scale. And this is where the 21 degrees is. Now, if the plane was 1650 off the ground, that would mean initially that this should be 1650 and this should be 1650. So in my diagram, which is definitely not looking to scale, these are both going to be 1650. And the question is, how far are the boats to the nearest meter? Now in my original diagram, the distance the boats were apart would be this long distance here. That should be the same distance as the top, obviously, because what we have here is a rectangle. So looking at my new diagram, I'm actually looking to find the length of this very top long piece here. And I'm going to call the piece from here to here X, and the piece from here to here I'm going to call Y. So let's take a look and let's draw the left triangle, and let's find the information we want in that one. So the left triangle looks like this. We have this being 1650. This is a right angle, and this is 21 degrees, and this is X. This is our hypotenuse, this is our opposite, and this is our adjacent. And obviously you're going to notice that we're using tan an awful lot here lately. The formula is tan of A is equal to opposite over adjacent, and the tan of 21, let's make our list. 1650 is our opposite, X is our adjacent, and 21 is our angle. The tan of 21 is equal to 1650 over X. Punching in the tan of 21 in our calculator, we're going to get 0.3839 is equal to 1650 over X. Let's put this over 1 and cross multiply. We're going to get 0.3839x is equal to 1650. To get the x by itself now, we're going to divide both sides by 0.3839. Those reduce to 1. 1x, or just x, is going to be equal to 4298. I know that seems like quite a big number, but take a look. If this is 1650 and this side's quite a bit longer, it being 4298 isn't a problem. Now let's look at our right triangle. And our right triangle looks like this, where this is 1650, this is 52, and this is Y. So making our list, we have 52, which is the angle, we have 1650, which is the opposite, and we have Y, which is the adjacent. Can't spell today. Our formula again is tan of A is equal to opposite over adjacent. Tan of 52 is equal to 1650 over y. The tan of 52 is 1.2800 if you round properly, and you get 1650 over y. Let's put this over 1 and cross multiply. 1.2800y is equal to 1650. To get y by itself, let's divide both sides by our decimal. Cross out. Y is equal to 1289. So what do we know? We know that this distance from here to here is equal to 4298, and this distance from here to here is equal to 1289. So to find the entire distance, I'm going to find now x plus y, which is 4298 plus 1289 is equal to 5587 meters. And you'll notice that my original question asked for my answer to be to the nearest meter, which is why I didn't round off. I knew these to be decimal points.